In a world where the universe itself bends, one man will discover the truth. The fourth dimension.
What is space-time? We all know the three main dimensions: height, width, and depth. When you add a temporal dimension to these spatial dimensions, you get the concept of space-time.
The first person to discuss what space-time can mean for us was Einstein, although he did not conceive the idea. He would expand upon this concept with the equivalence principle.
To explain this mathematically, according to Newton's second law of motion, force equals mass times acceleration. This force can also be written as force equals mass times the intensity of gravity. These statements are equivalent. If you are referring to the same object for mass, you can cancel it from both sides. This leaves you with acceleration being equivalent to the intensity of gravity.
Let's say you decide to drop a ball. Since it falls to the ground, you may presume that you're on Earth. However, there is another possibility. You could be in a spaceship accelerating up at the same rate as gravity. This means the ball isn't falling, the ship is rising into it. The equivalence principle states that since there's a force, similar to gravity, acting on the spaceship, the physics behaves like you are on Earth. With this in mind, Einstein then wondered how light would act in this situation. If a photon of light from this laser hits the wall of the rocket, there would be a slight curve in its path due to the wall's upward acceleration. The equivalence principle says this should also happen on Earth. But gravity depends on mass, and light has no mass. This led Einstein to the conclusion that something else was happening. Einstein reasoned that light curves in a gravitational field because space-time itself is being bent. To explain the curving light, Einstein figured that what made of space-time could be distorted by mass.
To demonstrate, imagine this is the fabric of space-time. When there's a small amount of mass, there is little impact. When a larger mass is added, space-time bends, pulling other objects in. In the right situation, this can create orbits between two objects.
If that sounds familiar, it's gravity.
Einstein modeled the relationship between mass and spacetime with the field equations. There are 10 equations which can be expressed by this formula. The left side of the equation represents the shape of spacetime, and the right side represents energy, matter, and pressure. To quote theoretical physicist John Wheeler, spacetime tells matter how to move, matter tells spacetime how to curve. Einstein's theories on relativity and spacetime were verified in 1922 during a solar eclipse. He predicted that spacetime would bend around the sun. This means light would as well. During this solar eclipse, photographs showed that the stars were not in their original positions. Einstein's theory said this happened because the light from the stars changed direction due to bent spacetime.
And that's not the only concept he predicted. He anticipated several phenomena in our universe, which revolutionized our understanding of spacetime. Thank you for watching.